Hello everyone and welcome to Takamori Robot. Today I am very excited to tell you about Takamori Robot's H.I.R.O TR-01-A robot. So this is a robot that you can build yourself in under 2 hours, and today we're going to unbox this and do that together. So inside are a bunch of different components. So let's take a look. It looks like we have some jumper cables. We have a breadboard. We have a bunch of components, including a Raspberry Pi Pico right there. We have servo motors, USB cable. This is the robot Cortex, and inside we have some plastic pieces to put the robot together. This is everything you need to put that robot together. All right, let's get started. So the first thing I'm going to do is I'm going to unwrap this bundle of servos, and I'm going to take 4 of them and pop them into each of these robot legs like this. Kind of has a Eiffel Tower like pattern on there, and we can just take them in like this. You might have some resistance, but you see the slit here, it allows a little bit of flex, and you can just pop it in like that. Don't jostle them too much, they're not completely secure. Just for now, just take them and then just take the servo. Make sure that the horn end is pointing out towards the back here. You can see a little gap here for the wire to go through, and just pop it in. These servos are not completely secured yet, although they are secured on 4 sides. You got to secure them in from the top, so that's where these clips come in. There's actually 2 different variants. If you actually see here, you can see that some of the clips are longer than the others. So we want to take these longer ones. We should have about 8 of them. So divide them into 2 different lines. These ones are a little bit longer than these ones. We'll take the longer ones and use them to clip down the servos onto the legs. So it takes a little bit of force, but if you push it, they should just pop in like that. So remember, these are the longer ones. So if you just push it, sometimes it takes a little bit of negotiating, and it just pops in like that. And do that to all 4 legs. Just push it and it snaps in. Easy, screwless installation. And one more. Push it, and it snaps in, just like that. Some of you may have noticed that there are similar mounting holes for motors on the Cortex itself, so we actually do the same thing. And we just take the motor and we just pop it in. And we can use these shorter clips, and the reason that the clips are shorter is because the printed circuit board here is actually thinner than these legs here. So push it, and it just pops in, like that. We do that twice for every motor on the board. Right, push it, and it pops in. Now let's do this for every servo. Sometimes they pop back out. You just gotta make sure that they're really in there. So now we have every single servo installed on the robot. Now we install the shoulders. So these are the robot's shoulders. And one thing you actually notice is that some of these are mirror images of each other. So the easiest way to show here on camera is the holes here. So these ones, they have the holes here on the bottom, but this one, it has holes on, from my perspective, the right side, your left. And this one here has a hole on your right side, my left. So that's actually important to note, especially when installing these. But don't worry too much, they'll actually be marked for you when they arrive at your door. So we're using 2 different kinds of components, the shoulders as well as these pivots. This is a servo pivot. We can pop it onto each one of these servos just like this. This cylinder here, it's in line with the motor shaft of the servo, which allows us to create kind of a hinge when we install one of these. When you install these shoulders, the hole will always be on the bottom and the other hole will always be facing behind the robot. So this is actually the front of the robot here where it has this header pins. And then here where there's no header pins on the back, that's the rear of the robot. And what we can actually do here, this one's a good one. And so it's essentially we coax it onto the cylinder on the bottom and then we just snap it on like that. It might take a little bit of doing, but don't give up. And let's see, let's find another one. So this one is the right one. Remember, hole faces the back. Hole faces the back. Don't worry, yours will be marked. So you slide it over the cylinder here, so it goes in, and you kind of bend the horn here and the top part of the shoulder so you can kind of coax it in. All right, let's do that 2 more times for the Cortex. I like to make sure that when I install it that the wires here are coming out and they're kind of directed towards the center here. This helps with wire management. This is the robot body, and then we have the shoulders connected. But the last thing we need to do is get the legs connected. As you can see, we have 4 more of these pivots and 4 legs. So we can just pop these onto all of the legs. And then there we go. So once I have that, it's the same process of just attaching the bottom of the pivot to the hold right there and just coaxing the top into place, like that. And there you have it. So now that the robot's structural components are put together, let's work on getting it wired up. Here on the servo motor, you have 3 different colored wires. You have yellow, red, and black or brown. I can't really tell in the light here, but so black or brown is ground or negative. Red is power, or 5 volts in this case, and yellow is PWM, or pulse width modulation. You'll learn more about that in another one of our tutorials. On the Cortex here, you have different labels. In this case, you have a LFL, which is left front leg, LFS, left front shoulder. Here you have LBS, left back shoulder, which is this one here, and then LBL, left back leg, which refers to this leg here. And then on the right side you have everything, all the same things but the opposite. So you have RFL, right front leg, RFS, right front shoulder, which is this one here, and then RBS, which is right back shoulder, and then RBL, right back leg. So let's start with LFL, left front leg, and then each pin is marked with a PWM power ground. So you take the cable and then you line up the cable with those pins there. So make sure that yellow matches with PWM, red matches with power, and black matches with ground, and just plug it in. And do that with the rest. So this one is left front shoulder, LFS. So connected to the servo connector for LFS, and then here we go. Make sure everything's lined up. This one is LBS. Make sure that you connect it to the LBS servo connector, and then PWM, ground, and power are lined up. Right. Let's do this with left LBL, and then right side, just repeat the whole entire process. And then do one final check, make sure that everything is connected correctly. One way to tell is there are no pins visible, and then yellow should be pointing forward. And now all your motors are wired in. Last step to at least make the robot functional is to include Raspberry Pi Pico. So Raspberry Pi Pico is a microcontroller by Raspberry Pi. It runs an RP2040, and this specific one is actually a Raspberry Pi Pico W. It has a Wi-Fi Bluetooth chip built in right here. And so what we're actually going to do is we're going to take this. You see these 2 sets of header pins in the center? We are actually going to take the Raspberry Pi Pico and we're going to just plug it in like this. And just pop it in. That's actually pretty satisfying. And Now, we can control all the motors on the board. Congratulations, you built your very own H.I.R.O robot. Was it fun to build? We worked very hard to take something that was conceptually complex, like robots, and make it something that you could complete in an afternoon. So, with the same energy, check out our next tutorials to learn how to make this guy move.